let's look at the properties that we have here of enlargement and reduction. I will highlight the ones that I need you guys to remember. Okay, remember some of them here have to do with the actual drawing of the enlargement and reduction, but I can't do that because I can't put a protractor and a compass here. So I can't exactly show you properly what these are talking about. Your teacher might be able to do that. But here we're going to focus on the actual rules of reducing and enlarging shapes. Nice. So when we enlarge and reduce shapes, all of the sides have to be in the same proportion. What does this remind you of, guys? That sentence sounds very familiar to me. Which other section did we run into that sentence? All sides in the same proportion. All sides in the same proportion. Where else did we run into that sentence, guys? Think, 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 think. Similarity. Thank you, thank you, thank you. That means these shapes have to be similar. We won't have congruent shapes this time because we are reducing or enlarging them. So they will not be the same, exact same shape. We're not just moving the same shape, okay? We're now enlarging or reducing them. So we are talking similar shapes. No, you're not. You are here to learn, and so is everybody else, okay? So that number that we use, the proportion, okay? We call it the scale factor, okay? We call it the scale factor. So it's going to tell you that your scale factor is either going to be greater than 1 or between 0 and 1. I did not say anything about less than 1. So your scale factor is either greater than 1, and if it's greater than 1, then it is a what? Is it an enlargement or a reduction? Read there. Is it an enlargement or a reduction? It's an enlargement. So if I say scale factor is 2, look here, greater than 1, then it is an enlargement. Then it is an enlargement. But if I say to you, the scale factor is between 0 and 1, so the scale factor is a half for instance, then it is a fraction between 0 and 1, it will be a reduction. It's important to know that so that after you draw your shape, you know if it looks right or if you maybe made a mistake or what. Okay, it's not so bad. It's not so bad. So you're going to look at the scale factors. I'm going to show you now how we're going to use our scale factors. I want you guys to take note of these two because our next section is area and perimeter of two-dimensional shapes. Okay, so we're going to need these 2 points when we're doing area and perimeter. Okay, for now, don't worry about it too much. Okay, but just keep those at the back of your mind. Please take a screenshot of this list, guys. Please, please, please. Yes, area and perimeter next, guys. Don't worry. Okay, so this is a nice shape that shows you enlarge means you make it bigger. Okay, so enlarge means make bigger and reduce means make smaller. Bigger, and here we have make smaller. Now, I'm going to need you guys to concentrate, especially from now on, and listen very carefully, okay? We are going to cover 2 options. Okay, we're going to cover 2 subsections here. So the first one is we're going to cover how do you enlarge or reduce the shape if you are given the scale factor, all right? And then we're going to cover how to find the scale factor if you're given the shapes. All right, so first one, we're going to use the scale factor to find the shapes. Second one, we're going to use the shapes to find the scale factor. Okay, so everybody listen. First one is we are given the scale factor. Okay, you can say this. Reduction is decrease. Well, yes, making smaller. Okay, so let's check what it says here. So remember, we were using our coordinate to show what happens. So our normal coordinate, ordinary coordinate is xy. So now we're going to use k for our scale factor. We're using k because it's a variable. We don't know what it is. Let's say we don't know what k is, right? It's our scale factor. So to find your new coordinates, you must multiply all of them by the scale factor. That's where the kx and ky come from. Now I know I might have lost a few of you here. Okay, I know I might have lost a few of you. So I'm going to go to the side here and explain properly. Let's say I have a shape, okay, with the coordinates 2, 3, 4, 3 also, and let's say 5 and 7. What kind of shape is this? What kind of shape is this? Hello? We're not listening. What kind of shape? Guys, if it has 3 points, it has 3 sides. It's a triangle. There we go. Great. So let's say I have a triangle, and I'm telling you guys that we are enlarging the shape with a scale factor. Let me write it at the bottom. Factor. I don't know why my handwriting is doing stupid there at the bottom and dancing. Scale factor of 3. Okay, so when I say you multiply each coordinate by the scale factor, this is what I mean. So now you're going to say 2, you're going to take your scale factor, say times 3, and 3 times 3. So what's my new coordinate? What are my new coordinate for the first one? Thank you. So the first one is, okay, let me move this. First one is now 6 and 9. Great. And then you go to the next one. 4 times 3 and 3 times 3. So new coordinates. Your coordinates is, thank you, 12 and 9. Then you do the same thing with the last one. 5 times 3 and 7 times 3. So my new coordinates, 15 and 21. And that will be an enlarged shape. How do I know that it is an enlarged shape? How do I know it is enlarged? When I will get back to you just now. Yes, we multiply 3 because that is our scale factor. We've been told that it was the scale factor there. So you take that 3 that you've been given, okay, and you multiply it by everybody here. Okay, there you go. Guys, how did I know this was an enlargement and not a reduction? Think of the points that we wrote down up there just now. No, it's not because the number increased. Well, sort of. Because the scale factor is greater than 1. Thank you, Hlulani. Go back to our points, guys. If the scale factor is greater than 1, it's a enlargement. If the scale factor is between 0 and 1, it's a reduction. Okay, so your new shape will be bigger than the old one. Okay, guys, are we with me? Do you guys want to do another one? Someone asked me what the scale factor is. The scale factor is the proportion of the sides. Okay, it's the proportion of the sides. Where did I lose you, Fatima? No. We always multiply, Desmarie. We always multiply. You never divide. Let me show you why you never. Okay, let me first take Fatima's question. Fatima? Yes, Fatima?
Hi, ma'am. How are you, ma'am?
Good, and you?
I'm fine, ma'am. Ma'am, where did you get the 3? Because Mina, I know our scaling factor is 1.
No. You have to be told the scale factor. And I told you in this example that it's a 3. Do you see that?
So they'll tell you in the question or scale factor is 3. What if they don't tell you?
They're going to tell you. If they don't tell you, they have to give you the shape. Remember, I said we're going to go over how to find the scale factor, but now you need to first know how to use it. Okay.
Okay. So use it by multiply.
You always multiply. Always, always, always. Okay.
So if it's divide, is reduction.
No, you always, Fatima, what does always mean?
Always, like never ever.
You never ever divide. I'm going to show you guys now what I mean. Okay. Always multiply. Are you with me? Let's do another example, guys, where I show you why you are never going to divide. So remind me again in the chat, we said, if it's a reduction, your scale factor is what? If it's a reduction, your scale factor is, remember we said an enlargement? Thank you, between 0 and 1. Give me a fraction, guys. Oh, geez. Never mind. Okay, give me a fraction. Thank you. Abu has given me a half. So let's do an example with a scale factor of a half. So I can show you guys what I mean when I say you always multiply. So let's see. Now I'm going to say my scale factor is a half. I'm going to give you a couple of coordinates and we're going to see what happens. Scale factor 1/2. Now, we need new coordinates, okay? We need new coordinates. I'm going to say my new coordinates are 4, 6, okay, 2, 2, and 10, 8. Now, we said you always multiply, right? Did we not say we always multiply? So guys, tell me, when you multiply by a half, what happens to the number? What happens to the number when you multiply it by a half? So I'm going to say 4 times 1/2. Thank you, Abu. It's divided by 2, isn't it? So what actually is happening to the coordinates? What's happening to the coordinates? They are halving. So then my new coordinates now are 2 and 3. Do you see that it's a reduction? There we go, Sanele. Do you see? I didn't divide, Umpimedze. Say 4 times a half and see what's going to happen. Say 4 times a half. I did not divide anyway. I did multiply, stuck to my word. Even here, we're going to say 2 times a half. Our scale factor is a half. There we go. 2 times a half. And again, 2 times a half. And it's going to give you 1 and 1. And the last one is going to be, then you use the odd number, Michael. I am struggling to believe that your name is Michael Jackson, but it's fine. And 8 times a half. So my last one is 5 and 4. Okay, guys. So now can you see that that was a reduction? It was a reduction because our scale factor was between 0 and 1. Do you see what I meant when I say always multiply? I did not divide even once. Look there. Okay, I did not divide even once. I took my scale factor and I multiplied it with all the coordinates. There we go. There we go. And there we go. And I saw someone said, what if it was an odd number? So let's say you have a coordinate that says 5 and 1. And my scale factor is a half. You do the same thing. You're going to say 5 times a half. Tell me, guys, what's 5 times a half and 1 times a half? Thank you. Thank you, Abu. So my coordinates will be 2,5 and 0,5. And you can plot 2,5 and 1 and 0,5, can't you? You just go halfway on the block. Let me show you. Okay, so instead of going all the way to 10, you plot it over there. That would be 9,5. So that's not a worry. You can still plot it even if it was odd numbers. Okay, are we good, guys? Are we feeling okay, sort of, about using our, scale factor to find the new coordinates? There we go. Okay, let's do this. Thank you very much, Jason. Thumbs up, thumbs down. Give me my thumbs up and thumbs down. I'm going to do one example just now with an actual shape so that you guys can see what it looks like. Okay. Are we good? Okay, so I haven't seen a thumbs down, so can I just go to the next example? And then if you don't understand, stop me. All right. Let me just go to the, excuse me, oh, my voice there. Now, we have a triangle. So I'm going to change the scale factor, otherwise it's not going to fit on my Cartesian plane, okay? I'm going to change the scale factor. Let's get rid of this and make it a 2. Scale factor of 2. Now, first, we have to plot our original triangle, okay? So original triangle is triangle ABC with the coordinates. A is 2, 3. So it's 2 over there and 3, so that's there. Next one is -6 and 3, so it's -6 and 3. And my last one is 5 and -2. Is there anyone who's still struggling with plotting coordinates? Speak now. Please speak now if you're still struggling a little bit with your coordinates so we can help you. No? Are you good? Okay. The scale factor is 2, sorry. Let me do this. There we go. The scale factor is 2. Okay. You're welcome. Now let me insert lines because we all know what happens when I try and draw these things. We're going to be here for the rest of the lesson with me trying to draw this triangle. And another one going there. And another one going there. So that is my original triangle. Is everyone fine with that? Now we have a scale factor of 2. What do we do again with the scale factor? Remind me in the chat. What do we do again with our scale factor? We multiply it with all the coordinates. So then for A prime, so my new coordinate, I'm going to call it A prime. It's going to be 2 times 2. Okay, maybe I shouldn't use green because I drew the original one with green. Maybe I should use blue. 2 times 2 and 3 times 2. Be patient with me if you have this. I'm doing this so that people can see where we get our new coordinates, okay? There we go. Thank you, Desmarie. I see you've already written A prime for me, and it'll be 4 and 6. Nice. B prime will be what? -6 times 2 and 3 times 2. Okay. And that will be, thank you, -12 and 6. And the last one is C prime, which will be 5 times 2 and -2 times 2, which is what? Nice. I saw someone wrote a nice summary there for me. This will be 10 and -4. Nice. Are we all happy about the multiplying coordinates part? Okay, now we know how to use our scale factor, I think. We're feeling a little bit more confident. So let me draw the new triangle. So I don't have -12 on my Cartesian plane, but I can sort of estimate where it would be. Okay, so A prime would be at 4, which is over there, and 6. So it's there. -12 is like 2 blocks that way. So it's like there. And 6 again. And then the last one is 10 and -4, which is over there. Now look, guys. Tell me what you see about these 2 triangles that I'm about to draw now. One is bigger, but what? Do they not look like the exact same triangle? Just increased, right? One is just enlarged, but they look like the exact same triangle. Nice, guys. So do you guys think you would be able to enlarge or reduce the shape if you were given a scale factor? Do you guys think you're feeling good about it? Thumbs up, thumbs down. How are we feeling? Nice. I see yeses everywhere. Sorry, my eyes are hurting a little bit. Maybe I should switch on the light and stop being stubborn. Let me go switch on the light. Yes, so they are similar triangles, not congruent, but similar triangles. Okay, I'm so surprised nobody asked questions. So you guys are just catching on about this. Kotatsu says, I'm not sure about reduction. We're going to do one just, I think a bit later, we have a reduction one. Now, I want to quickly cover finding the scale factor. Okay. I'm going to quickly cover finding the scale factor. Now, let's go up. We know how to use it. Now let's go find the scale factor. So now we have two shapes. I want to know what scale did I use to enlarge or reduce the following shapes. So first things first, you need to know which one is the original shape. Which one is the original one? Between the gray one and the lime green one? Which one is my original shape? Or yellow? I feel like I'm colorblind. I don't know if it's green or what. It's the gray one because it doesn't have the little prime little goli gauge, right? Wonderful, guys. Yes. So now let's write the coordinates of my gray one. We have W, we have X, and we have Y. My coordinates for W, X, and Y, let's hear. W, what's my coordinate for W? Anybody? 3, 4. Remember, we start with the one on the X, guys. So it's 3 first and 4. And then X, it's okay, Sai. How do we do, what's the coordinate for X? We are on X now, which is down here. There we go, 3, 2. And the last one is Y. Y? 5, 2. Nice. Now let's check the new coordinates from the enlarged shape. W prime, X prime, Y prime. What's the coordinate for W prime? Coordinates for W prime. Okay, 9, 10. That would be true. Okay, X prime. 9, 4. And the last one, Y prime. 15, 4. Nice. And now we need to find our scale factor. So guys, when you find your scale factor, we are going to use the lengths of the shape. Lengths of the sides. So what I mean is you're going to take the original, nope, the new one, sorry, divided by the original one. And that's going to give you your scale factor. Now I need to know what's the length of XY, guys. To go from there to there, you can either use your number line or you can just count the blocks. What's the length of XY? How did you find the number? I haven't found it. Should I zoom in for you guys? Let me zoom in a little bit. There we go. Is that better? Is that a little better? There we go. 6. Okay, so let me actually write it. Over the original x, y. So it's 6 over. What is the length of the original? Paul, be careful. What's the length of the original? 2. So then what's the proportion of the new side to the original? What's 6 over 2? It's 3. Nice. Now, I'm going to caution you to be careful, and you are going to do it with all the sides. Okay, you're going to do it with all the sides. We didn't multiply the coordinates, guys. We're trying to find the scale factor. You have to do it with all the sides to make sure that they are all in proportion. Remember, a condition of similar triangles, remember, is all of the sides have to be in proportion. So not just one, you have to make sure that all of them are in proportion so that all of them have the same scale of 3. So what I mean is now you're going to go to W prime x prime, and you're going to divide it by wx. How many units is w prime x prime? Let me zoom in a little bit for you. W prime x prime over here. Thank you very much. It's 6. And what's the units for just wx? It's 2 again. So our scale is still 3. But I said all sides, guys. I said all sides. So what's missing? We still have to do the wy. How are we going to find the length of wy, guys? Oratile, where did I lose you? Where did I lose you, Oratile? Remember to raise your hand, guys, if you want me to explain something. Yes, Nhlakanipho, Pythagoras. We're going to use Pythagoras. Oratile, we are still finding it. So you're going to take the corresponding sides. So Oratile, remember, wx corresponds with w prime x prime. Do you see those ones that are both blue? So what I did was you take the new shape, which is the one with the primes, and you divide it by the length of the old shapes. Okay, now if you look at the new shape, how long is wx? Let's count. 1, 2, 3, 4, 5, 6. That's where this 6 comes from. And then you look at the old shape, it's 1, 2. That's where this 2 comes from. And then you just find your answer. 6 divided by 2 is 3. Are we good? And then we are done with those corresponding sides. We move to different corresponding sides. So now we are on xy and x prime, y prime. Let's count again. 1, 2, 3, 4, 5, 6. That's where this 6 comes from. And then 1, 2. That's where this 2 comes from. And then you divide again and you are at 3. Nice. So now I asked, I can't believe this person's going to do repairs while I'm teaching. Can I just close my window, guys? Give me 1 second. No, the dog is not going to be in today's lesson, guys. Unfortunately not. Unfortunately not. So sorry. Whoever missed the dog last week, maybe he'll be there next week. Sorry, guys. Hi, but Michael Jackson is going through a lot. What's going on? Okay, let's get back to it. So now we found the proportion for the two sides, right? But then I said to you guys, we still need to find the proportion for wy, this side. And I asked you, how are we going to find the length for this side? And someone answered correctly and said, we're going to use Pythagoras. Okay, are we good? Have I found everyone? Woo! Let's hear what Fatima has to say. Fatima?
Yes, ma'am. Ma'am,
Hmm.
the division is confusing. It's confusing.
What's confusing? You take the sides of the new shape and you divide it by the side of the old shape.
Or like the sides, like the long side, specifically.
No, all of them, Fatima, the corresponding sides. W prime x prime corresponds with WX, isn't it?
Yes.
So we
The
took,
corresponding one.
yes.
Oh,
So now we are on
because
WY, which corresponds with W prime Y prime. Do you see where we are now?
yes.
Nice. Now let's use Pythagoras and find the lengths of WY and of W prime Y prime. So Pythagoras says WX squared plus XY squared. I don't know what's going on with my handwriting. Let's do Pythagoras quickly. Did anybody make the sum or work it out? It's what? WX squared plus WY squared equals, nope, plus W. What's going on? XY squared. Yo, guys, my brain is tired. Plus XY squared is equal to WY, which is what we want. Now, how long was WX, guys? How long was WX? Nipo, you're doing the prime one. I'm not there yet. I'm still doing the original one, which is the little baby one there on the side. How long was WX, guys? Thank you. It was 2. We're not listening. Not W prime X prime, WX, the old one. It was 2. So it's 2 squared. And how long was XY, which is this one? How long was X? There we go. It was 2. Thank you, Kaya. We are on the small shape, guys. This is squared. So then 2 squared is how much? 4 plus 4. 4 plus 4 is not 16. Be careful. WY squared. Therefore, WY is the square root of 8. Leave it as the square root of 8. Oh, but you can simplify. You can simplify, guys. Square root of, no, you can't. Square root of 8, square root of 8. You can't simplify it. So now we know WY is square root of 8. Okay. So this is the square root of 8. Now we need W prime, Y prime. And I saw someone write the answer for me just now, and that was Nipo. Thank you very much, Nipo. Okay, Nipo says W prime X prime squared plus X prime Y prime squared equals W prime Y prime squared, which was 6 squared plus 6 squared. And that gave me 36 plus 36. Therefore, W prime Y prime is the square root of 72. Now we do the same thing. Right? So you take the new one, which was W prime Y prime divided by the old one, which was just WY. That means the root 72 divided by root of 8. And what's the answer? What's the answer? What's root of 72 divided by the root of 8? Anyone who might still be with me and awake? There we go. So we can officially say that our scale factor is nice, guys. This one needs a little bit more concentration than using the scale factor, ne? I know I might have lost some people. Let's do a thumbs up, thumbs down. Let's do a thumbs up, thumbs down. Check in. It's here. Mamelo, hands up. Where did I lose you? There we go. I like that Mamelo just always doesn't hesitate. Yes, Mamelo.
Hi, ma'am.
Hello.
Ma'am, you lost me here by the wx squared plus xy squared equals to wy squared.
Oh, Mamelo, did you forget Pythagoras?
Yes, ma'am.
You forgot Pythagoras. That's a sin, Mamelo. This is a right angle triangle. Let's revise it over here. Nah? Remember, when we had a right angled, Mamelo, you're gonna make me draw. You know drawing is not my thing, but it's fine. Okay, we have, there you go, not that bad. We have a right angle triangle, right?
Yes, ma'am.
And we have A, B, C. What did Pythagoras say about the sides of this?
Ma'am,
AB squared. Pythagoras said AB squared plus, which one?
ac squared.
Squared will give you
ac.
AC squared. You agree with this, right?
Yes, ma'am.
Now let's go see here. We had two different triangles. Do you agree?
Yes, ma'am.
Now I need you to look over here where I'm pointing with the green arrow. You see that's WX squared plus XY squared is WY squared.
Yes, ma'am.
WX squared is that side. Are you with me?
Yes, ma'am.
XY is that one. And that will give you the long side, which was WY. You see?
Yes, ma'am.
And how long was WX?
It's 2 squared.
That's where the
Ma'am.
two squares come from.
Oh.
And then after that, we had to do it with a big triangle as well. So now this time, do you see that they have little kolikis at the top? W prime, X prime. Look
Yes,
at it.
ma'am.
So W prime, X prime is this side over here. And then X prime, Y prime is this side over here. And that gave us the long side. Now, how long was W prime, X prime, Mamelo?
6 squared.
Hmm?
6 squared.
Yeah, but how long was it? How many units was
6
WX prime?
units.
It was 6, right?
Yes, ma'am.
And that's where these 6s come from.
Yes, ma'am.
Have I found you?
Yes, ma'am.
Wonderful, 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 wonderful.
Thank you,
I can't,
ma'am.
you're welcome. Guys, I can't help but say kolikis. I don't know. Kolikis is those little man. I don't know how to explain it. It's these symbols at the top when we say prime. These symbols. I'm sorry, guys. I'll try and stop saying that. Okay, anyone else that I had lost? Please raise your hand now. Please, please, please. Nope. Have I sort of found? Okay. Okay, I have sort of found it. Okay, guys, you see how long this is? Let me zoom out so you guys can take screenshots if you want. There we go. So you guys have to check all 3 sides, okay? Otherwise, you will lose marks. You cannot just check one side and then say that therefore the scale factor is 3 because, okay, it's possible that maybe it's not a scale factor. Maybe it's a transformation or something. Okay. How many marks would this be? Ooh. Okay, you'll get a mark for this division over here, that division over there, the 2 Pythagoras, the last division, and the, ooh, how many marks was that? 1, 2, 3, 4, 5, 6. About 6 marks. All right. Abu says 25 marks. Okay, who's in the mood for a brain break, guys? Let's have our hands up. Let's have a little brain break quickly. Wonderful, wonderful, wonderful. Noctula, you ready? Is Noctula ready? Noctula, you can unmute.
Hi, ma'am.
There we go. Hello.
So, ma'am,
So,
are you doing the spring break?
yes, give me 1 second to find it. There we go. Would you rather have bright purple hair or bright purple teeth?
Bright purple hair, ma'am.
And then what if your outfit is yellow?
Then, ma'am,
I'm
it's
just
yellow.
asking. What
Then
if your
it's
outfit is
yellow, ma'am.
orange, guys? Gwen is like, calm down now.
Ma'am, then it's yellow.
Oh my goodness. You're gonna look like
Red,
Turkish
wear
delights or
beneath. Oh, my
something.
God.
Oh my goodness. You're literally gonna look like Turkish delights. Guys, some of you don't comb your hair. It's gonna look like some plant. Imagine. Eh. Our guys, you're traumatizing us. Tika's laughing. Chloe, are you ready?
Hi, ma'am.
Hi, Chloe. Would you rather only go to school in summer or in winter?
In winter, ma'am. Summer,
In
I want to be in my pool. Summer, I want to be in my pool. I want to be in front of my fan.
our
Yeah.
guys, I would rather go to school in summer. In
No,
winter,
ma'am.
stay at
I
home
walk to and from school and it's like, no. It's
and be
like,
warm. Guys, come on. You guys want to get cold. Imagine you're wearing a skirt. Woo.
ma'am, that's why I'm my fan.
Whoever just posted a YouTube video, you will get kicked out. Stop it. Okay. Oh, you guys wear pants. You guys are lucky. Guys, you know I went to a school where we wore skirts all year round, including winter. I can't even. Like we literally, and we didn't have stockings. Like we had long gray socks, but we didn't have stockings. So it would be like a skirt and then a long gray sock, but your knees were always out. Woo! Yo, guys. Tanduletu. It was sad, guys. Now the way I get, hi Tando. Would you rather have an unlimited gift card from McDonald's or an unlimited gift card from the cinema so you can watch movies and snacks for free? Which one would you rather have? The cinema. I also choose cinema. I'm tired of
Yes,
McDonald's. Every day McDonald's. Ah, what guys? I would also choose the cinema. Nice choice, Tando.
I mean, if you think about it, you can get like free snacks instead of just
That's
McDonald's.
the thing. And you can get like an outing, you can go out. Guys, I'm always home lately. At least if I know I have free movies, I'll be motivated to go out. Some of you guys sleep at 10. Me, I'd go like now after the lesson, go watch a movie for free.
Yeah, exactly.
Guys, these ones want McFlurries forever. Amen. Kaya, are you ready? Kaya? There we go.
Yes, ma'am, I'm ready, ma'am. I'm ready.
Okay, Kaya, would you rather have a massive pimple or a huge booger on a school photo?
Yes, ma'am, that one is a difficult one, eh? But I'd rather choose the poga, ma'am, hey, than a
Yeah,
pimple.
at least you can take
Nah,
it out. Guys, at least you
hey,
can
ma'am,
imagine having a pimple, you can't do anything about it. It's like, imagine it being here. Like,
my poga I can remove it, ma'am. It makes more sense, ma'am. It makes more sense.
exactly. Guys,
Oh, just imagine I have a pimple. It's so big, ma'am. Nah, it won't make any sense.
exactly. Guys,
No, but
It's
then your picture
alike,
is done.
man.
You can't remove the booger from your picture.
it's
Oh,
fine. You have
hey.
5 years in high school. You'll deal with the
Oh
other
my
pictures. I get it, guys. Oh, pimples. Pella, if you have a pimple on your school photo, guys, that means at least for the next 2 weeks, you have that pimple every day going to school with that big anger, guys. Imagine if it's on your nose. Imagine if it's like right there. Our guys, please be focused. Yeah, our guys. You. Imra's like, none of them, none of the above. I'm good. Thanks for asking. Okay, bye. Everyone who's having personal chat, I will block the chat. I promise you. Guys, stop it. All right, behave. Now we are done with our brain break. Ooh, I love that people are like pimple any day.
Miss Cat, sorry, I just want to disturb you there quickly to just tell you guys that we let you guys rename yourselves, not to name yourselves ridiculous things, but just in case you needed to rename yourself to your actual name. So if I see a lot more people renaming themselves to Batman and Michael Jackson and other random people, I think we will remove that, because imagine now Miss Cat must say, oh, well done, Batman. That's so ridiculous. So please let us not, abuse our privileges. Thanks, Miss Cat.
Thank you, Miss Simone. Thank you. Okay. I hope you guys heard that. Now, let us do this one. So first of all, which one is the original shape, guys? Is it the bigger one or the smaller one? Yes, it's fine to have an emoji. Which one is the original shape, guys? Look carefully. Should I zoom in a bit? Let me do this. It's the bigger one, guys. Remember, the original one only has the letters. Look here. We just have Q, R, S, T. But the smaller one has the prime on top. The kolikis, remember? So the smaller one is the second one. That means the bigger one is the original. Okay. So remember, guys, you guys have to know how to identify this. Otherwise, you're going to get it wrong. Because if you thought the smaller one was original, you're going to think this was a enlargement. You see that? So it might cost you your marks. So you need to be able to identify that so that you know. If the bigger one is original, that means we have a reduction. Nice. Sorry, guys. I tried to zoom in a bit for you guys. I tried to zoom in a bit for you guys. Okay, let's do like so. Okay, now let's find our scale factor. Let's find our scale factor. First thing is first, I am going to write my coordinates. Okay. S, okay. Doesn't make sense to start from S. I'm going to start from Q, R, S, and T. Let's go. Coordinates. Coordinates. Oh, Nhlakanipho already has scale factor. No, it isn't given in this case, right? We are finding it, okay? So the coordinates for Q are 4, -6. And R, it's 4, -2. S, 0, -2. And T, 0, -6. Nice. And then our transformation or our movement was to Q prime is, where is it? There. 2 and -3. Oh, you can already see the scale factor. R prime, 2 and -1. S prime. Ma'am, what if you put the coordinates of the prime letters only? Would that affect anything? Not necessarily, unless you're going to use them in the calculation, okay? I'll show you just now. 0 and -1, and T is 0 and -3. Remember, we're doing the sides, guys, okay? So how long is the side SR? How long is SR, guys? The original SR, the big triangle, it's 4. And then S prime, R prime. S prime, R prime is 2. So that means we have a half. Nice. So now let's do RQ prime. and the proper RQ. This is a square, right? So they're all the same. It's 2/4. 1/2. But do you see that I'm showing all of them, guys? T prime Q prime over TQ is also 2/4, which is 1/2. And the last one is S prime T prime over S2, 2/4 still, which is 1/2. Okay, guys, do you see why it's important to put the correct one on at the correct spot? Do you see that? You have to put the new one at the top and the old one at the bottom, because then your scale factor is 1/2, which is between 0 and 1. So that tells you that this was a what? This was a what? If the scale factor is between 0 and 1, it tells us this was a reduction. Whereas if you made a mistake and swapped them around, it would have been an enlargement. So therefore, we have a reduction. And does it make sense? Yes, you can see in your image. You can see in your image that the original one is bigger than the new one. Okay, guys, do we understand? Let me do this and make you guys get a screenshot. I'm going to go down, scroll down now for you guys to get a question. Remember, on Thursday, we are doing exam questions. Okay, so I'm going to go down now for you guys to try a question for me before Thursday, if you can. Okay, don't feel pressurized. If you have time and if you can, please try it. Okay, Mr. Papi's not coming out today. He's very far. Please try this question, guys.